Welcome, gang. This is Computer Science 470, which is computer graphics, if I'm not mistaken. And I very well could be, since this is the first day of class. Let's see. So today what we're going to do mainly is just kind of give an overview of the course. I'm going to go over the syllabus and do some things like that. So let's see if I can't find my syllabus to start with. Oh, by the way, as those of you who had me last quarter, you know, I try to put up a background, usually something from a sci-fi movie or TV show or a video game. And this one we're starting with one that's really, really easy, of course, the set of Star Trek: The Next Generation. Some of them that I put up are pretty obscure. So it was a game last quarter. Students would try to figure out what background does Mike have behind him. So we may play that game again this time as well. We'll have to see. Okay. So this is the syllabus here. Now the syllabus is up on Moodle. And I encourage you to bring up the Moodle stuff and have that out and available. That way, if we lose video, I can just keep talking because you'll have stuff in front of you, notes, documents that I refer to, anything that I have up that I put up on Cam. I'll have it up on Moodle before class, so it's there. So like I say, if we lose the video component, we just keep going right through, and this worked really, really well last time. So first thing about this course, it is being offered in a hybrid model. Mainly it's going to be online, but we'll talk about some of the implications of the hybrid model as we go through today. We do have a classroom. It's Napkin Hall 244, and of course the class is from 11 to 12:15 Monday, Wednesday, Friday. Everybody's got my email address there. My office hours, I didn't hold them today, but I'll probably start holding them tomorrow. Monday, Wednesday, Friday from 10 to 11. Then, of course, we have this class, and then I sometimes have faculty meetings, but then from 1 to 2, and then I've got another class after that. So 2 hours, but they're broken up from 10 to 11 and from 1 to 2. And then Tuesday, Thursday, it's just a stretch from 10 to 12 on Tuesday, Thursday. There's my Zoom. Also, my office number is 115. The prerequisites for this class are 325, and there's no required textbook for the class. I'm going to make available all of the various notes. I'm going to skip down to the COVID implications because that's one of the things everybody always wonders about. So it's a hybrid class, and as I have here, unless and until your instructor receives both doses of the vaccine, we'll probably be providing instruction remotely over Zoom. I have a number of underlying health conditions, nothing that slows me down or anything like that, but it's enough that if I did come down with COVID, it might make the prognosis not so positive. So I'm being extraordinarily careful about that. So most of your interaction with me is going to be over Zoom. I talked to my doctor on Monday, and as the announcements have come out, the vaccines are going to start going out in about 2 weeks, but those are going to be to frontline healthcare workers and then people in nursing homes. The next tranche after that, no one really knows, but I've heard people with underlying conditions and teachers are two of the higher risk groups. So who knows? Maybe January. I'm thinking February. And if it starts in February, that's really too late to affect this quarter. So probably expect all of my lectures to be virtual like this, although there is some chance that towards the end of the quarter, I might be able to meet face-to-face with you guys towards the very end, but I wouldn't hold my breath if I were you. This class is very, as we'll talk about in a minute, there are components of this class that are individual programming assignments, and there are parts of this class that are team-based. I can't, and I won't, make personal recommendations to you guys as to how much actual physical face-to-face interactions you want to have with your team members. Sadly, the virus has become extremely politicized. And so there are some people, members of my family, who treat it as absolutely, oh, it's like a cold. And I've had several of my family members who've had it now, and thankfully all of them have recovered well. But if you tend to be a kind of individual who thinks, oh, there's nothing to it, and you get it and you have a cold for a few days, then that just reinforces your, oh, there's nothing to it. The news is making, a mountain out of a molehill. We've been lucky no one in our family has, that we know of, has specifically died of COVID-19. We did have one family member, he's elderly, in a nursing home, and he was hospitalized for about a week, but he recovered. But your family situation may be far different from my family situation. So again, I'm not going to, it's very personal right now. I can say is if you look at the numbers, we're going through the highest infection rates ever. Not only are we the country with the highest amounts of infection rates in the entire world, we're now at the highest levels of infection we've ever had through the entire 9 months of the pandemic. Hospitalizations are reaching record highs, and it's not just located to like New York, it's in cities across the nation. Those are facts. I'm sorry if you disagree with them, but those are facts. Deaths have not reached the peak that they were at, but they have increased quite substantially from the levels that we had gotten down to. And if you look at the curve, it doesn't show much of an inflection. So those are going up. So in some ways, if you want to look at actual risk of catching the virus, just numerically, mathematically, if you look at how widespread it is, you're probably more likely to catch it now than ever in the last 9 months. So anyway, again, I know that this is political for some people, and I apologize for that, but these are facts. And the important facts, because much of the class is team-based, and some teams may want to meet in person. In fact, I suspect that probably most of you will want to meet in person, because most of your classes are in person, and that's fine. And people in your age range have a very low risk of a negative outcome, unless you have a serious underlying medical condition. There may be others among you who are much more risk averse and would prefer to do your teamwork, over Zoom or Skype or whatever you're currently using. I would ask that if you have a team and there is one or two members who want to interact with the team that way, that you be understanding. You do not know everyone's family situations. Someone may live at home with someone who's immunocompromised. And in that case, it's the risk profile for each of us varies dramatically, is what I'm trying to say. So we all need to be considerate of what others are needing to do. And guys, I know we're all tired of this damn thing. You have no idea how tired of it I am. But we're reaching the end. You know, in 4 or 5 months, everybody who wants to be vaccinated will be vaccinated. And within 6 months or so, we may still be wearing masks for a little while, but things are going to get back to normal pretty quickly. But we've got this next 2 months that things are not normal. And please don't think, oh, the vaccine's almost here, so I can stop worrying about all of this, because that's not true. So anyway, that's my view on COVID. I guess my big word is be prepared to be flexible. The state's now back at phase 2, and hopefully everything will go well. But no one knows what the result of Thanksgiving is going to be on the progress of the pandemic. And while I hope this won't happen, I would be mentally prepared if we had to go back online for a month or two, following Christmas. I'm not saying that will happen. I've got no inside information that will happen. It probably will not happen. I'm just saying be flexible and be prepared, and don't get all, upset if things change, because things could change. Okay? So you may have questions, but let's hold them until I've gone over all of this, and then you can ask your questions. So what's this course about? It's about 1 hour and 15 minutes, 3 days a week. That's what you call a mic joke. It's some people call them dad jokes, but I'm not a dad, so we call them mic jokes. You will hear them occasionally, groan silently, or at least have your mic muted. They're along the same level of, a man walks into a bar. Ouch. That's the level that Mike O'Neill finds funny, which says a lot about him, I suppose. Okay, so what's this course about for real? What are the topics covered? Well, it's really 2 things. One thing is an introduction to, and you guys don't have to be staring at this, y'all can look at me while I'm talking about it, and I'll just read it. But it's 2 things. It's one is an introduction to the approaches and the algorithms that we use to generate 3D computer graphics. So that part is going to consist of us going through the theoretical nature of how computer graphics work. We are going to look carefully at the math that underlies 3D polygonal rendering systems. And this is going to depend heavily on linear algebra to do things like rotation and scaling and virtual cameras and stuff like that. It's helpful if you've had linear algebra before this class. It's not a strict prerequisite for the class. And I'm going to cover over the next few lectures next week the basics of what you need, vectors and matrices and stuff like that. The math isn't hard, but it is important. Now we're going to be doing all of that, covering all of that math and covering all those algorithms so that you will be able to implement a small rendering engine over the course of the quarter. There are 5 programming assignments that we're going to have this quarter, 5 individual programming assignments. And these assignments build on one another. And by the time you get through, the first 2 are pretty easy. The second 2 are not easy. not easy. So keep that in mind. The first 2 are pretty easy. The second 2 are not easy. But they're rewarding because if you get them, and most students do get them, the vast majority of students get them, you will have built a little system that can render polygonal objects that can rotate them, and you will have made them solid, and you will have added a lighting model to them, and it'll be really, really cool. You'll have a little teeny tiny graphics engine that you built, okay, that you will have built from the basic math and algorithms. So it'll give you a very deep understanding of how computer graphics actually work. We'll end up with a program that's the last program. The fifth program doesn't quite build on everything else, but it's super cool because it's ray tracing. Everybody loves ray tracing. Ray tracing is how you get all those cool reflections and shadows and all of that kind of stuff. So you're going to build these things, right? So that's kind of the first part of the class. I cover the math. I'll help you out. You'll write the programming assignments, and you'll build a little engine from scratch, absolutely from scratch. So you're going to learn the nuts and bolts of computer graphics. The second part of the class is a group project that's more self-directed, and it deals with making, it deals really with learning some of the tools that are commonly used in modern game development. And in the syllabus I have, environments such as the Unreal Engine, Unity, or the Cry engine, but we're going to use the Epic Unreal Engine. It's my favorite of those three. Why? Unity, those games just don't look as good. It's a simpler engine. It is usually the engine that students start with, who are interested in games. So some of you may have programmed Unity. Are there any of you, just tell me in chat, that have programmed in Unity? Any of you who built some games or game levels or anything like that in Unity? Okay, I'm beginning to see a few people say that they've done that. So some people have messed around with it. Has anybody played around with the Unreal Engine? I would expect the answer is going to be no on that one. The learning curve's a little steeper on the Unreal Engine, but it's but out of the box, the kind of effects you can get are nicer. Unreal is AAA games up until recently. Maybe they still do use Unreal, so that's the reason why I'll push you guys to use the Unreal Engine. I've had a few teams use the Cry engine, and gosh, you can get beautiful results with the Crytek engine. But every team that's tried it has really complained that the learning curve is super steep on the Cry engine. So Unreal looks really good, and difficulty of climbing the learning curve seems to be somewhere in the middle between Unity and Cry. So that's kind of why we're going to use the Unreal Engine. It's freely available. I'll also encourage you guys to use tools like Maya. Those are freely available. There's tons and tons of assets out there that you can use. The whole point of the second part of the class, the team project, is for you to start to become familiar with the tools that are actually out there for building video games. I'm not going to teach that to you. That's going to be self-directed. I'll tell you, look at Unreal, look at Maya, right? But it's going to be up to you guys to play with it. Why don't I teach it? It's probably more fun for you guys to learn it on your own. And quite frankly, that technology changes. And I've got so many things on my plate that I don't have time to keep up with all of the details. So that's the real reason. But I thought very carefully about the course, and about 2/3 of it is the math and writing the programs to build a little graphic engine from scratch on your own. And about 1/3 of the class is a team project to learn how to use the tools that are out there. And I think together this approach gives a very balanced, useful course in computer graphics. So, if you'll know how to use Unreal, and you'll know how to build game levels, and you'll probably know how to play around with Maya, or at least how to import objects and stuff like that. And most teams come up generating, you may be surprised, at very good-looking games. I mean, maybe not at the level of Red Dead Redemption 2, but certainly better than Skyrim. Right. Now, obviously, they're not nearly as big as that, but yeah, you can build out some levels pretty quickly and pretty nicely. Okay, so that's that. Let's see, what's the catalog description for 470? The prerequisite is 325. The catalog says fundamentals of 2- and 3-dimensional computer graphics. Topics include line drawing, polygon rendering, clipping algorithms, 2- and 3-dimensional transformations, and projection techniques. We're going to cover all of that plus substantially more. We're going to also cover lighting and reflection models. We're going to cover shading techniques, and we are going to cover the basics of ray tracing. As I already said, there's going to be 5 programming assignments that are going to be given throughout the quarter. One thing that that is missing from this class is there are no exams. Some of you may have already known that if you've talked to people who've had this class before, but if not, there is not a single exam. Instead, there are programming assignments. And you might say, well, Mike, how are you going to, most classes don't do programming assignments instead of exams. Some of you probably wish they did, because we all know that most of the work goes into writing the programming assignments. The main reason why most props don't count programming assignments very high is it's hard to know that the student wrote the program, just being straight up, flat honest. And that's unfortunate because it leads to a situation. When I was a student, and yes, I was once a student, I thought it sucked because, I would spend, 20 hours, on each of my 5 or 6 programming assignments, and that'd be worth 15% of the course, and I didn't spend nearly that much time studying for the exams, all told, and the exams were, 80% of the course. And I was like, this isn't fair. I'm spending all my time and doing all my work and learning all of the stuff, writing these programming assignments, and then that counts 15 points, and the exams are 80, and the other 5 got lost in the trash can or were homework assignments. That just doesn't seem fair. So a few years ago, for some of my classes, I've implemented a policy where students meet with me one-on-one for 15 minutes to explain their program to me. If you can sit down and talk to me about your program for 15 minutes, and I ask you questions, well, how did you do this? Or why did you make that design decision? Or can you show me where you did this thing? Or, oh, can you tweak this little thing to do this? If you wrote the program, it's easy for you to answer those questions and make those changes. And in fact, most students who actually wrote the program are so excited they want to show it off, and they want to tell me it would take 45 minutes if I just let them talk rather than the 15 minutes that we have. Because look, if you wrote it, you're proud of it, right? If you didn't write it, you come in and you're so nervous. I'll ask you something you don't know. Now, some students are just normally nervous Nellies to begin with too, but after a few questions, they calm down if they really wrote it because they realize there's nothing to be scared of. But if you write your own programs, it's obvious. And so by doing that and having these little interviews, and one thing is I grade them on the spot. So you know your grade at the end of that 15-minute meeting. And students like that because you get instant feedback on what your grade is. It's a lot of work for me as a faculty member, a tremendous amount of work to meet with every student on every programming assignment for 15 minutes. There are 24 of you, so you start adding that up, right? That's 8 hours straight meetings, right, for each of the 5 programming assignments. So it gets to be a lot of meetings, but it's worth it because I think the students get a lot out of it, and it's more fair. In a class like graphics, your grade shouldn't depend on whether you memorize some formulas. Your grade should depend on, well, did you generate the programs that generated some cool graphics? And if the answer is yes, well, then I think you ought to get a good grade. Okay, as far as teams are concerned, Fridays are generally going to be team days. We're going to look over a day-by-day outline here at the end of this, but normally Monday and Wednesdays are going to be lecture days, and Fridays are normally going to be team days, is the way this thing's going to work out. So Fridays are generally going to be days to either work on the project or present on your project, things like that, where Monday and Wednesday I'll be doing the lectures. We do have, as I mentioned here a moment ago at the top, we do have Neptune Hall 244 for this class. And even though I will not physically be there, for those of you who, again, we talked about the whole risk profile thing, for those of you who are meeting in classes already and feel comfortable with that, if you're comfortable with meeting in person and doing all of that, then I would encourage you to show up in 244, at least on Fridays, because that would make it easy for your teams to get together. Also, too, you guys are going to be presenting on most Fridays, and you can put together a presentation where it's all by Zoom and you switch between different cameras. That's doable. But it might be easier if you guys were physically present, social distancing, wearing masks, but physically present so that, you know, each person could just get up in front of the camera and give their part of the spiel. Because again, I'm going to be here on Zoom and I'm going to need to see the presentations. So keep that in mind. What's the grading procedure? I already said there are no exams. The individual programs are going to be 75% of your grade, and the group project is going to be 25% of your grade. I'm going to grade the programs. There are going to be 5 of them. Each of them will be worth 15 points. That's a letter grade and a half, right? Program grades are going to be based on you demonstrating the program running and achieving the specified output, and a review of the code, and the ability of the student to explain how his or her code works. Normally in the programming assignment, I'll have a rough rubric of how I'm going to grade it. 15 points for this, 10 points for this, etc. So generally, you should have a pretty good idea of how it works. And I will say that in this class and in my artificial intelligence class, where I grade programs in the same manner, I've been doing this now for about 5 years, so hundreds of students, and all of that, one student has seriously disagreed with the grade that I assigned his project over all that time. So normally students are generally quite happy with the grade they get. A couple of students who, I'm excluding a couple of students who clearly cheated. They clearly didn't write their program. Frequently they are not happy. Most of the time those students will in the end admit that no, they didn't write their code, so they knew what they were getting into. Please don't do that. All right, no exams, like I said. The grading scale, 10-point university grading scale, collaboration policy. Individual programming assignments are individual in nature. Sharing of code is forbidden. You can talk about your program with people in the class within reason. You cannot show code. But in English, you can talk about how you solved a problem as long as you're not showing code. And you can show students, other students, your program running, so you guys can look at like how your programs work, to make sure that, you know, everybody's doing the same thing and meeting, you know, the requirements that are in the handout. So you can show people, you can demo your program running. You can talk about how you solved the problem, but you cannot show code. You can't share code. You can't take code off the internet. That's a no-no. And what do I mean by that? Well, if you need to do file I/O in your program, obviously you can go and look up, and let's say we're writing in Java. You can, although I think we're writing in Python. I don't know. I'll have to go and look. You can go and you can obviously look up online how people do file I/O, and you know, how you know, throw and try and catch exceptions and stuff like that in your I/O to make it robust. Don't just cut, copy, and paste, right? But you know, obviously there are tons of examples out there, and you should use those to help you learn how to do what you need to do. So when I say you can't take code from the internet, I don't mean you can't look at code on the internet. That would be crazy. Obviously you can and you should. Look at examples, you know, please. But don't patchwork your program together with pieces of code you barely understand. Never take a solution off the internet that uses something that you don't understand how it works. That's terrible, because if there's a bug in it, that's going to cause a problem. And if I ask you, so why did you do it this way? You know, you're an answer of, you know, because the honest answer is because that's the way they did it online. It's not going to be a good answer that you want to give me during a 15-minute code walkthrough. So, yes, you can use the internet as a resource, obviously. You can look at examples of how things are done online, obviously, but you need to write your own code, equally obviously. As I say in the syllabus here, if I become convinced that your knowledge of a solution is insufficient for you to have written that solution yourself, I will consider the collaboration policy to have been violated. If you violate the policy, the collaboration policy, you'll get a 0 in the class. If it's really egregious, I might try to get you kicked out of the university. Well, let's see other things that are in here. If you have some sort of a learning disability, physical disability, whatever, you need to be in contact with Testing and Disability Services so that we can set up some accommodations. If you have COVID accommodations, you need to let me know about that too. As I've indicated, you know, we're late in this pandemic now. All we have to do is make it through this quarter. Things will start to return to normal next quarter in the spring. So, you know, I know exams. So, you know, technically you're supposed to go through the university and get COVID accommodations documented. In this class, if you know, I'm saying that, you know, if you want to work in your teams remotely, I'm okay with that. You know, the lectures are going to be online. There aren't going to be any exams. All of the code review sessions are going to be over Zoom. So for this particular class, if you decide you don't want to step foot in the classroom, I'm not going to make you. That's the bottom line. Okay. On the other hand, again, if you're comfortable with face-to-face meetings, you may find it easier to work in teams if you are doing that face-to-face. Totally up to you guys. Classroom conduct policy. I've thought about this a lot. You might say, how can you have a classroom conduct policy, Mike, if all the classes are going to be conducted over Zoom? Well, I've learned through this pandemic. Back in the spring, I've recorded all of my lectures, and basically what I did is I built PowerPoint decks, and I recorded me talking through those PowerPoint decks and didn't use any video. And then I would post the lectures up online, and students could watch them at their convenience. That worked okay. I think it was probably the best I could do under the initial circumstances. Last quarter, I modified things in the fall, and I taught everything live online through Zoom like I'm doing this one. And that worked pretty good. I think students got pretty much out of the AI class what they would have gotten with me standing in front of the room. I don't see how it added too much. Students can ask questions. We've got the chat. In fact, there was a lot more joking around in chat here online last quarter than happens in the classroom. So I think actually I even got some students on the evaluation so that they actually preferred it. So, but there was one problem. What is the problem? Any of you who've had me for a class before this last 9 months know that when you walk in my classroom, I make you close your laptops and turn off your phones. And if a phone rings or I see a student look down and start answering a text message, I give them a very, very, very hard time. And also showing up late, I give students a very hard time about that. And some students think, Mike is such a bastard. He's such a, you can insert your own word there. But I do it for a reason. And I do it out of love, as they say. I do. Because distraction, when in a classroom situation, I have control over that classroom and I can make sure there are no distractions. I won't let you look at your laptops. I won't let you look at your phone. I make you sit there for an hour and 15 minutes and, and if you start to fall asleep, I kick you out of class. So basically it's a bubble, right? A learning bubble for an hour and 15 minutes. And that works real well, I think. And I've gotten some crap from students over the years about it, but I think everybody really realizes that it's actually a lot better to run class that way. Some profs, they can lecture to an empty classroom. I've seen profs, lecture to classes of students with their feet propped up on their desk reading a newspaper or something like that. And I'm like, hell no, I'm not going to do that. You have a perfect right to prop your feet up and read a newspaper, but not in my classroom. And if you really want to read a paper and prop your feet up, go do it in the student union, right? I mean, do it, because it's groups of humans are weird in that a group takes on a personality. And if an instructor makes it clear that he or she doesn't care if students pay attention, no one pays attention. Well, there are the 20% of you who hang on every word I say, and I love you for that. But 80% of you, the normal people, they take their cues from the people around them, and they just start goofing off. So, but we're not in the classroom. So, Mike, what does this have to do with a classroom conduct policy? Well, I am going to go ahead and share the screen again so you guys can look at this. Come on, where's my screen? Here we go. So I'm experimenting this quarter, and I'm going to try something new, because you never learn if you don't try something new. So I'm going to try to recreate our learning bubble this quarter. So though our lectures are going to be held over Zoom, I am going to have a classroom conduct policy. So one, you need to attend the lectures virtually from a quiet physical location with minimal distractions. If you want, and you're happy with it, you can meet in the classroom, right? And you can open up your laptop, and you can, I'll be on every desk in my own little window. All right, so you can do that. But, if you don't want to go into the classroom, you can find a quiet corner, or in your dorm room if it's quiet there. But anyway, you need to be in a quiet physical location with minimal distractions for the lecture. Do not multitask during the lecture. Focus on the lecture material. Now, I can't make you not multitask, all right? But I can beg you not to multitask, and I can plead with you to focus on the lecture material. 3, your mobile phone needs to be off or in airplane mode. You shouldn't take voice calls during the lecture. I am actually, like I told you guys, oh well, my phone's invisible. I guess because it's black. That is so weird. Anyway, that is bizarre. But anyway, I'm dialed in, so I'm not going to get any phone calls because I'm dialed into the lecture. Now, here's the difference. Here's the new thing. All students must have the camera on the device that they are using to Zoom into the lectures on for the duration of the lecture. And occasionally I'll pull up my my student images and look at your smiling faces or your frowning faces or your puzzled faces. But I want you to have your camera on. Your mic should be muted, of course, but the camera should be on. And I'm doing this, to help force you to focus on the lecture and join from a quiet location. I became aware last quarter that I really needed to do something when during the middle of my lecture, a student who accidentally unmuted his phone, it was a him, the entire class listened to the individual order takeout, right, through the drive-through window at a fast food joint, which was kind of embarrassing for the student and a bit annoying as the instructor. But I thought, and humorous, we all laugh, but I thought on that, and I'm like, how much is this student really getting out of my lecture where I'm covering, the mathematics of machine learning, when that individual is clearly listening in, on a phone and focusing more on getting, I've forgotten if it was fried chicken or tacos, but is focusing more on getting lunch than on lecture. And the answer is, you can't follow. It was chicken wings. Thank you, Eric. Was it you, Eric, that was the sad student that did it, or you just remember that it was chicken wings? There quickly just, no, it wasn't me. It wasn't me. But I have no idea. You may be in this class, you may not. I don't remember the student. So don't feel like I'm picking on you, because I'm not. But yeah, it was chicken wings. I do remember that. It was hilarious. But the point is that if I get you guys to run your cams, you're going to be a whole lot less likely to try to pull something like that, and it will help you. I promise it will help you learn the material, because when we get deep into how ray tracing works, or how you build composite matrices to do in place rotations, or simulate a virtual camera, you can't just listen to that in the background and go, oh yeah, I got it, because it's not gonna work. You might say, well, why does it even effing matter, Mike? You're not gonna test me on it. Oh, yes, I am testing you on it. Writing that program is the ultimate test, because if you don't understand the algorithms and the math that we went through, you're not going to be able to program it. No way, no shape, no form. So it's not that I'm not testing you. I am testing you. I'm testing you by having you build the programs that implement the math and the algorithms that we're going over. So don't think, oh, I'm not going to get tested on this so I can blow it off. It's exactly the opposite. You're going to be tested in more detail, in a sense, because I'm making you write the programs. Does that make sense? Okay. Does it make sense? I hope it does. Lectures are going to be recorded so that they can be reviewed. I'm not planning to record any of the student presentations. You need to be present in person, or virtually, online, in person, whatever. You need to be present for however we want to define present for the presentations. And the reason for that is that another aspect of this class that I haven't talked about is how are the projects graded. I will grade the programming assignments. That's 75% of the class. I'm going to grade that. The project, that is peer graded, student graded. You will have a survey to fill out about each presentation, and I'm going to put those surveys on Moodle, so they'll be electronic. In years past, they've been on paper. But you'll fill those out, and those surveys will be used to generate the grades on the projects. Okay? So the students themselves will grade the project. Now, there is a safety valve to make sure you guys play fair. And the safety valve is I myself will also score every project. But if the system works right, I will take my scores and throw them in the trash. Okay? Huh? What does he say? If I feel that you guys aren't really trying to grade everybody fairly, and sometimes some students have a very hard time grading other students. They want to give everybody 100, and they think that they're doing a good thing if they give everybody 100 on everything. 100 and a 0 is exactly the same thing in my book, because it provides no discrimination between the projects. And let's face it, some projects are going to be better, some projects are going to be worse. And I've never lived through a class where everyone's project was absolutely perfect. It doesn't happen, right? We are humans. We are not perfect. Normally what I find when I look at my grades compared to the grades that the class generate is the top 1 or 2 projects, me and the students always agree. The bottom 1 or 2 or 3 projects, me and the students always agree. The projects in the middle, the order varies, because they're in the middle, and it's more, if something's really good, everybody recognizes, oh God, that team, they put a ton of work in it, and that looks fantastic. And if a team doesn't really try that hard, it's pretty obvious that the team didn't try very hard. If you're in the middle, it's a little harder to figure out. Okay, so this is the course outline, day by day, meeting by meeting. Now, I didn't break out the contents of the lectures because sometimes I move a little faster, sometimes I move a little slower. I get through all the material by the end of the class, but it does vary a little bit. So I'm just saying when we have lectures. And so the first thing to look at is today we're doing an introduction and a lecture, although I'm not going to have much time for a lecture. And Friday is going to be a group project day where you're going to form your teams and you're going to start conceptualizing your projects. I've got a handout about that I'm going to go over here in a minute. And then on Monday and Wednesday of next week, there'll be lecture. And then on Friday of next week, there'll be another in-class group project meeting. Again, in class, you can define how that's going to work. And then after that, the Fridays will generally be group project updates, presentations where every team will speak for 7 or 8 minutes and give an update on their project. And you can see after that, December 18th, January 8th, January 15th, you're getting these weekly update meetings. The week of Martin Luther King, there's not a Friday presentation. You might say, why not? Because the following week are project midterm presentations. The project midterm presentation, these are longer, 20 minutes, or so for each team, and they break over 2 whole days to go through those. So that's why we didn't do a breakout session on that Friday, because the very next week you're going to be given midterm project presentations. And the next week I currently have scheduled that I'm going to give a lecture then too. But then these last couple of weeks you're working on programming assignments, and then we've got the final project presentations, which come, I guess, 3 weeks after the midterm. And so that's kind of how we're gonna go. Things could change a little bit, but usually I stick pretty close to this. You can also see that I've got the due dates for the assignments, when our one-on-one meetings are going to be. Those generally are on Tuesdays and Thursdays, or when our one-on-one meetings are going to be. They're so exhausting that I might clip a lecture or two if I can get away with it. But if not, that's fine. It just depends. Sometimes I drop a lecture or two, and also in winter, because the weather can get bad, a lecture or two might go by the wayside, or they might not. I don't know. It just depends on how quickly we move through the material. It varies a little bit. But anyway, you can see that we are going to meet on Friday, in the sense that I'm going to be here on Zoom to answer questions, but you guys are going to be doing teamwork, okay? And that's going to also be for the following Friday. And then our last day before we break for Christmas is when you're going to give your first team group update. So by that point, right, we'll have been 2.5 weeks into this, and or your team should have formed for 2 weeks. And so I would expect you to begin to have stuff that you can show by 2.5 weeks from now. Okay? All right, let's see. I was also going to give you a better idea of what I'm expecting on Friday. Let me go and share that. So here's a little document on team formation and project conceptualization. The classroom time on the 4th will be devoted to team formation and project conceptualization. Again, if you're comfortable, I would encourage you guys to actually meet in the classroom. It might make it easier to divvy up into teams if you're doing that, especially if you're not quite sure who you're going to team up with. And again, as soon as you form your team, you can go off in another room or in a corner somewhere, so it's not like everybody has to stay bunched together in the room. But anyway, from 11 to 12:15 on Friday, you guys will meet. I'll be on Zoom, available to answer questions. Students should take that time to form themselves into teams of 3 or 4. I strongly prefer 4 students per team. The last I looked, there were 24 students in this class, and that allows for 6 teams of 4 students each exactly. 6 teams is a good number of teams. 4 people per team is a good number of students per team. Why? Because some students do drop this class. The programming assignments get to them. Not a lot, but some do drop. And if you have a team and you lose a person, you'll still be with a team of 3. And team of 3 is still a reasonable team size. I don't want teams starting out with only 3 people in them, though, because if we lose someone, then it'll be you'll be down to 2, and 2 is, I mean, that's not much of a team when you get down to 2 people. So that's what I'm looking for there. So what are the deliverables that I'm going to be expecting on Friday? I'm going to expect the following items at 12:30, by 12:30 on Friday, December 4th. So on Friday by 12:30, I'm going to be expecting, so that's 15 minutes after the class officially ends, a list of the members of your team. For each team member, I want the first and last name of the team member. I want the preferred email address. Some of you like your tech addresses, some of you like a Gmail address or whatever, but I want your preferred email address, and I want your CWID so that I can verify that you are you. Your campus-wide ID. I want you to list one of the above members as the instructor team interface, the ITI. Is the ITI the team leader? Could be, not necessarily. Do teams have to have a team leader? Could be, not necessarily. I'm going to allow your teams to form the way you want them to form. Most people, in general, feel most comfortable with having someone in charge to kind of coordinate things. But there are other people who work better in kind of a equal collaborative environment. The problem with that is it becomes harder to coordinate, but some people it works well for them. I'm not going to make you do it one way or the other. So, but I am going to say that there's got to be somebody on the team that is my interface. So for example, this email that I'm expecting from each team, the team interface, the instructor team interface individual should be the person who emails me that information. And when we do presentations, you'll have to send me your presentation ahead of time. Well, the ITI should send me the presentation, and I do want them ahead of time. It'll be in the handouts that I give for each of them. But having them available ahead of time means that I'll be able to look over it before class. I'll need the name of your team. Every team needs to form a name. Be original. You cannot use team name, as one team once did that, and that was cute the first time. Or unnamed team. I had a team name themselves that one time. But please give a name that includes untitled. That was the name of a team last year, exactly, untitled. Enter name is another good example of a bad name. Thank you, Eric. So anyway, be creative, show some originality. Why do I have you guys pick a team name? It's a good team building exercise for the first day. It gets you guys all working with one another, and is a good way to get you to solve a little problem on day one. I will also want a brief description, 1 to 3 paragraphs outlining your initial ideas of what your team will focus on. It is okay if things change between week 1 and week 2 as to what you want to work on. I want you guys to start brainstorming and have some ideas down. Don't think of it as locked in stone, however, because I recognize it's the first day, things could change. But I would like you guys to try to focus on something. I'll give you some hints. I'm not generally extremely interested in gameplay mechanics. I personally don't like first-person shooters. I hate them. That's a strong word. I don't hate them. They're not for me. First-person shooters are not for me. I like games like open world games. I loved The Witcher 3. I played Skyrim quite a bit. Never played the main quest line on Skyrim. Witcher 3, I only played the main quest line about halfway through. I just like to go exploring, get out on my little boat, and watch the sunset or whatever. I played RDR2 a little bit. That was nice. I'm not so much into the gunfights of it, but it's a beautiful, beautiful world and well worth checking out. I loved Skyrim. The graphics in Skyrim look crappy by today's standards, but I loved the NPC player AI. And sometimes you can call me an odd person, but sometimes I would just follow an NPC around through an entire Skyrim day and watch what they did. And it was fascinating. They'd get up in the morning, they would go to work. Then they would, around noon, go to the tavern for lunch. They'd go back to work. Typical person. They would work until about close to sunset. Then they would go to the tavern, where they would eat dinner and hang out in the tavern. Some would hang out in the tavern longer than others. And then most would go home, go to bed, go to sleep, wake up the next day and do it all over again. But it was fascinating that they had a life, and it made the cities in Skyrim seem more alive than any other major game that I've played. Even something like RDR2, which is gorgeous, and the AI on, like, if you go hunting, is great because it really seems alive. But you go into town and everybody has their recorded lines and stuff like that, and they're just waiting for you to interact with them. They don't really have loops like they talk about in Westworld. Loved Mass Effect, the entire series. Well, I loved Mass Effect 2. Mass Effect 1 was good. Mass Effect 3 made me want to vomit when I got to the end of it. But before I got to the end of it, I liked it. And they came out with some DLC after the end, after the game had been published. It kind of redeemed a little bit, where you got to party with your whole crew before they go off and got massacred. I tried to play Mass Effect Andromeda. It was the first Mass Effect game I never finished because it was boring. But anyway, I love the Mass Effect series. That gives you an idea of what I like. But what I like and what you like are completely different things, and that's fine. I just don't – the focus of this class is on graphics. So, building environments that are interesting in some way is what I would like you to focus on. Some people build environments that look a lot like Skyrim, right? Like I said, you explore an island, or you explore a dungeon, or you explore a cave, or you explore some combination of environments. Those are all fun. One of the best projects that I ever saw was either last year or the year before. There was a team that built an infinite room, and they constructed that thing by hand, and you could watch them every meeting, how they solved problems. And in the end, it was so slick the way they had that thing set up. So it was a room that if you entered it in one direction, like walk infinitely. But if you like backed your way through it, you saw that from another perspective, the room was actually really small, and it was a wonderful, cool illusion. There were other teams that have done things like time travel, where they have an environment, but they build 3 different versions of the environment. One, where it's like the past and it's active, and one like where it's sort of, dilapidated, and one where it's in complete ruins. And they had a cool little in-game device or trick that you could move backwards or forwards in time. And really what they would do is they would just teleport you from one set of coordinates to the same set of coordinates in the other environment. And it worked out. It was really slick. It was cool. So thinking about building environments, what kind of environment would you like to build out? That sort of thing is what I'm interested in. Okay, now I have talked and talked and talked. My voice is almost gone. Questions for me. I think I answered the what types of things should we think about as an example. It says videos will be on YouTube. Will YouTube be emailed to us or on Moodle? Alan, the way that works is I'll post links to the videos in Moodle. I will have the videos on YouTube, but they'll be unlisted. You'll need the link to get to the video. So that's the way we'll do that. Let's see, other questions in here. Oh, this one's someone recruiting team members. That's good. Are there questions for me about the organization of the class and what we're going to do?
I have just one. This is Stephanie. Hi, Dr. O'Neill. My question was, so we'll be meeting again on Zoom on Friday, or are we just free to meet? Or I'm a little bit unclear.
I am going to be here on Zoom, and if you need, if your team has some questions for me, I'll be happy to answer them. There's no need for every one of you to fire up Zoom. I'm going to be here and be available for you guys.
Okay.
If that makes sense.
It does.
At some point in time, it might be cool if we, I don't know, it would require me getting a grad student. At some point in time, if you guys are meeting in the classroom, having some sort of a setup where maybe, we can Zoom me up on the projector, or something like that. That might seem a little bit more like a class, if you want to do that. I know Dr. Box has done that in some of his classes.
Gotcha. Thank you.
So Andrew asked, so we are doing smaller projects on our own and also working towards the group project simultaneously, correct? Yes, I would say you will be doing programming assignments. They're going to build on one another, so you can think of it as a project, but there'll be individual programming assignments, and those are individual. You can't share code, all the stuff we talked about there. Those you're going to meet with me one-on-one. If you look at the syllabus, you'll see the dates that are marked in like purple for one-on-one meetings. I'll put up the sign-up sheet, so you'll be able to sign up for a time, and we'll conduct those over Zoom. So while that's going on, also in parallel, you're going to be working on your group project. And again, I have you give presentations throughout the quarter to make sure that you're actually working on the project, because otherwise it would be way too tempting to just push everything to the end. So does everybody understand that? Any questions about that? Any other questions about that? Okay, so Friday, you guys will form up into teams by 12:30 on Friday. I'm going to expect emails from each team. I encourage you, if you're comfortable, to meet up in class. If not, you need to figure out a way. You could join. If there are some of you who do not feel comfortable meeting in person, those of you can join up on Zoom here. That might be a way of forming a virtual team that way. I will be on Zoom myself, available to answer questions. Okay, gang. I didn't get to the little lecture 0 I had. I may cover that on Monday. It's basically about virtual actors, and we're not going to learn anything about virtual actors this quarter, but I'm fascinated by it. So maybe I'll go ahead and give that lecture before we jump into the math on Monday. But anyway, I'll see you guys, most of you, on Friday, and take care and have fun. Talk to you later. Bye-bye.